Electricity powers almost everything we use, from lights, fans, and laptops to giant factories and cities. But have you ever wondered what electricity actually is? In this video, we'll break it down, from the tiniest particles and atoms to the power systems that run the modern world. Let's start at the atomic level. Every material in the universe is made of atoms. In the center of an atom is the nucleus, containing protons and neutrons. Around the nucleus are tiny particles called electrons, which move in orbits. In metals like copper, some electrons, called free electrons, aren't tightly attached. They can move from atom to atom easily. When we push these electrons to move in the same direction, we create an electric current, and that's what we call electricity. Now, not all materials allow electrons to move. Conductors, like copper or aluminum, have lots of free electrons and allow electricity to flow easily. That's why we use copper for wires. Insulators, like rubber or plastic, hold their electrons tightly and don't let current flow. That's why we cover wires with these materials, to keep the electricity safely inside. When you see a power cable, it's really a conductor at the core with an insulating layer around it for safety. Let's build a simple electrical circuit. A basic circuit has a power source, such as a battery, some wires, a load like a light bulb, and often a switch. When we close the switch, electrons flow from the battery's negative terminal through the wire, pass through the bulb, and return to the positive terminal. This flow of electrons carries energy, which lights the bulb. In any circuit, three key things determine how electricity behaves: voltage, current, and resistance. Think of electricity like water in a pipe. Voltage is the pressure that pushes the water, or in this case, the electrons. Current is the flow, how many electrons are moving. Resistance is like the narrowness of the pipe. It slows the flow down. These are linked by Ohm's law. Voltage equals current times resistance, or simply, V equals I times R. For example, if we have a 12-volt battery and a resistance of 6 ohms, we'll get 2 amps of current. That's Ohm's law in action. As electrons move through circuits, they transfer energy. In a light bulb, the filament resists the flow, heats up, and glows, producing light. In a toaster, the wires heat up and create heat. Every electrical device works by controlling this flow of electrons to produce light, heat, motion, or sound. When electricity flows through a wire, it creates an invisible magnetic field around it. This link between electricity and magnetism is called electromagnetism, and it's the principle behind motors, generators, and transformers. Transformers use electromagnetism to increase or decrease voltage levels. For example, stepping up voltage for transmission across power lines and stepping it down before it enters your home. We also have components like capacitors, which store electrical energy temporarily and release it quickly when needed, like a burst of energy to smooth out power in circuits or flash a camera light. Finally, electricity can flow in two different ways: direct current, or DC, and alternating current, or AC. In DC, electrons move in one constant direction, like the current from a battery. In AC, the electrons change direction rapidly, in most homes 50 or 60 times per second, depending on where you live. AC is used to supply power to our homes and businesses because it's more efficient to transmit over long distances. Inside devices like your phone or laptop, AC is converted back into DC because that's what electronics use. So, from tiny electrons in atoms to the giant grids that power entire cities, electricity is all about the movement and control of electric charge. It's one of the most important forces behind our modern world. If you found this explanation helpful, don't forget to like the video, subscribe to Electrical Engineering Mindset, and let us know in the comments what topic you'd like to see next.